Okay, so this is the first of the questions. So we want to undo the derivative with the antiderivative. So we have to split this one up. So I'm just going to carry the sign along. So go slow, 2x to the fifth over x minus root x over x. And remember, to take the antiderivative is just like the derivative. We have to have x to a power. So I'm going to carry that along, and then I've got plus 2. These cancel, so I get x to the fourth. And these cancel, so I get x to the negative 1/2, right? This is x to the 1, and we want everything to be up in the numerator. So that means the antiderivative, so what can I take the derivative of to get sine? So that would be negative cosine, and I carry the 4 along. I carry this 2 along, and I add 1 to the exponent. So I get this, carry the negative along, add 1 to the exponent, over 1/2 plus c. So I'm just going to invest a moment to just fix it up. So I get plus 2/5 x to the fifth minus 2 x to the 1/2 plus c. All right, so that's D, homework D. And then on homework E, I had a request for number 6. All right, so number 6 says we're taking a piece of cardboard that's a square, so 3 feet everywhere. And we're going to cut out a square out of each of the corners, just a tiny little thing to kind of make like the top of the copier paper box. So these little X's here, right, are the same as these little X's here. So all of these are the same X's. So that's going to be the height of my box will be the height x, right? Lifting it up. So I want to find the volume of this box. So the length and the width is not drawn to scale, but these two distances will be 3 minus 2 x's, right? Because I'm going to have x here and an x here. So I'm going to have a height of x, a length, and a width of 3 minus 2x. So I've already got it in one equation. There's no constraint in this one. Instead of multiplying it out, I'm just going to go take the derivative. So I know product rule and chain rule are in play, but you know how to do that. So first, d second. So bring the 2 down. 3 minus 2x to the 1 power times the derivative of the inside, which is negative 2, plus second d first. Okay, so I'm setting that equal to 0. Now I want you to be smart and think about it. Don't go just plowing through and multiplying everything out. I see that there's a common 3 minus 2x term that's in common. Okay, so if I factor that out, so factoring that out of this term gives me a negative 4x. This negative 2 and a 2 and an x. If I factor 3 minus 2x out of this term, I get one more 3 minus 2x term. All right, so I get 3 minus 2x is equal to 0. And if I join these together, I get negative 6x plus 3 equals 0. So this gives me x equal 3/2, and this gives me x equal 1/2. Okay. So do they both make sense? Does only one make sense? Let's think about it. So if I take this 3 foot long thing, this piece of cardboard, and I turn up side lengths, if this is all 3 from here to here, and I turn up side lengths of 3/2, there's no box, right? There's no height. So this is not a legitimate answer. So this is the only answer. All right, so that was 6 then. Someone had a question on number 8. Number 8 is another antiderivative. Antiderivatives are hard, so make sure you're treating them with healthy respect. They're not going away, so make sure that you're getting very careful with them. Okay, so I see this -1, so I'm going to rewrite it so that I see the fraction that it is. All right, so sometimes just rewriting it, you can see, wait a minute, I can see this is arctan, right? So you really have to know that the derivative of arctan is 1 over 1 plus x squared. So this is the antiderivative, so you have to recognize it. So f of x will be the antiderivative of 4 will give me 4x, The antiderivative of this will give me, carry along the -3, and then take the antiderivative here, and I get inverse tangent of x plus c. Okay, so remember, this is the information to help you solve for c. So I'm going to plug in x equal 1 and put in y equal 0. So put in x equal 1 and set y equal to 0. Okay, so what is arctangent of 1? So that's the angle so that when I take the tangent, I get 1. And remember, arctangent has that restricted domain, has to be between positive pi over 2 and negative pi over 2. So this here is going to be pi over 4. So this is equal to 0. Okay, so now I can subtract this over. So I get 3 pi over 4 minus 4 is equal to c. So remember, c is not the answer. The answer is what is the function, so that when I take the derivative of it, I get that with this initial condition. So that's the answer. All right, so that was number 8. So the next request was 13 on this same assignment. So 3E, number 13. Okay, so I've got a rectangle that's going to be inscribed or underneath this equation, y equal 8x squared. So my rectangle is going to be like this, right? Where the corners of the rectangle touch the parabola. Okay. So I need to find the width and the height to find the area of this rectangle. So the area will be this width. So let me just use a little color here. So this is a distance x and this is a distance x. So the width all the way across will be 2x. And then what's the height? This distance here will be the y value. And that's where I use the function. And since this one's not squared or anything, I'm just going to go through and just multiply this out. Now I'm going to take the derivative. And I'm setting it equal to 0 because I'm finding the critical numbers, right? So 16 is 8x squared. So that gives me x squared is 2. So plus or minus root 2 is x. So that's what these two x values are. And let's just go back and look at what the question says. Find the dimensions of the rectangle. So the width of the rectangle will be 2 of those root x's, right? I'm sorry, 2 of those 2 root x's, right? Because this is a root 2 and this is a root 2. And then the height of the rectangle is going to be what the y value is, right? It's going to be what the y value is when I plug in root 2. So I'll get 8 minus 2 or 6. So that's the height. All right. Let's move on to, well, let me stop there.